Hello viewers, welcome to UNC virtual class. I am Prangyalin Sahoo, lecturer of BSc Computer Science Department, and today's lectures I am going to discuss one of very important core part of the unprocessed field, that's your concept about pipelining. Here is a table of contents which I will discuss on today's class one by one. First, I will discuss concept about pipelining. After that, I will discuss why processor use pipelining concept. Then after, I will discuss concept about pipeline hazards. And lastly, I will explain branch pipelining structures in case ARM processors. So now to start our initial concept, there's your concept about pipeline. In general way, the pipelining concept to be used when a processor executes an individual instructions in a sequence of steps or stages. That means the computer pipeline is divided in stages. Each stage completes a part of instruction in parallel, and here each stages are connected one to the other end to form a pipe. Instruction enter at one end and progress through the stages, and finally that to be exits at the other end. Okay, so this is all about the concept about the pipelining. Now the question arises, what are the benefits? Whenever we have used the pipelining concept, it provides one benefits for executing multiple number of instructions and simultaneously by overlapping with each others. And also another functionality that to be provides the next job to be starting its executions before the first job complete executions. Okay, so now the question arises, what are the stages or what are the steps that we uses for individual instruction execution in an efficient way? So now to check the process of pipelining through the different stages providing the efficient job executions. So now to check the stages or the process of pipe. Here is the structure or process of pipelining. As you know, the pipelining to be executed every individual instruction by acquiring or consisting number of stages. In case of ARM processors, that to be acquiring or consisting 6 number of stages. So what is the function of each stages? Here the first is that's your fetch. The fetch stage to be instructs for fetching all over the instructions whatever to be required for executing the given job from the memory locations. Now goes to the next phase, that's your decode. Here the decode phase to be provides it to see what set of instruction it is. Now goes to the next phase, that's your registers. The register phase to be provides access any operands that may be required from the register bank. Now goes to the next phase, that's your ALU. As we know, the ALU terms to be used for performing any types of arithmetical or logical calculations in between your computer systems. Here is also the ALU phase combines the operands to form the result or a memory address. Now goes to the next locations, that's your memory. Here the memory phase to be provides access memory for a data operands if that to be necessary. Now goes to the next phase, that's your RES, that's your also registers. Here this phase to be provides write the result back to the register bank. That means whatever the interpretations, resultant elements to be required for storing, for viewing the output above screens. So in this case the register bank RES phase to be used. So by using these 6 stages, all over the individual instructions to be executed in an efficient way. Here this figures to be views that there is 3 instructions to be executed in parallel ways. But I will already discussing in case of pipelining, when multiple number of jobs to be executed, if the second job to be needed for its starting executions before the completion of the first job, that will be also possible. In this case also same, here the job to be started before the completion of the job 1 executions. Similarly, the job 3 to be started its executions before the completion of the second job. So this is the concept about the process of pipelines. Okay, now the question arises why we have used the pipelining concept. That means why the processor used the pipelining concept. In general way, the processor used the pipelining concept by acquiring two benefits. So what are they? The first one is the hardware utilizations. That means for hardware utilization of every resources in an appropriate way when the processor used the pipelining concept. And the second one is the CPU throughput. That means as we know the pipelining concept to be provides for executing multiple number of jobs in parallel way. So here the CPU throughput is much more. So by using these two advantages, the processor used the concept of pipelining. So now goes to the next concept, the sure pipelining hazards. What is pipelining hazards? Here the pipelining hazard situations to be arise when any instructions that prevents the next instruction in the instruction string from being executing during its designated clock cycles. And here hazard reduce the performance from the idle speed up gained by pipelining. That means the pipelining hazard concept to be initiated when any other instructions to be executed their job by occurring as an operand of the previous instructions resultant outcomes. In this case the pipelining hazards to be initiated. That means when any instructions that to be executed, in this case the instruction to be holds one operands that to be resultant of other instructions. Okay. In general way, this pipelining hazards to be appear in different ways, and that to be normally categorized by using three format. The first one is the structural hazards. So what is structural hazards? The structural hazards to be arise from resource conflict when the hardware cannot support all possible combination of instruction in simultaneously overlapped executions. That means if the program was to be executed multiple number of instructions in simultaneously in a given time periods, here all over the hardware resources to be very conflict that cannot be understand some instructions which is to be executed in between the multiple instruction overlapping executions. So here the structural hazard concept to be initiated. Now goes to the next types of hazards, that's your data hazards. So what is data hazards? The data hazards to be arise when an instruction depends of the result of a previous instructions in a way that is exposed by the overlapping of instruction in the pipelines. That means in this case when the any instruction executing by acquiring some other resultant instructions element as an format of operand. Here it to be uses the data hazard concept. Now goes to the next classes hazards, that's your control hazards. The control hazards to be arise from the pipelining of branches and other instruction that changes the PC. That means if by using some constant multiple number of instructions that to be executed, but at the time of execution if any types of modifications to be occurs above the constant that to be compulsory affect the given PC, and that is to be called as control hazards. So this is all about concept of pipelining hazards. Now to see how that to be structurally implemented in case of pipelining concept. Here we check this figures to be states two instructions that to be executed in parallel way, but the job 2 to be requires as an operand of the first instruction resultant outcomes. So this process of executions to be called as pipelining hazards. Okay. So now goes to the next concept, that sure branch pipelining behavior. So what is pipeline branch behavior? As you know the term branch to be initiated when multiple number of jobs to be executed by using certain conditions. That means by using some iterative looping conditions through which all over the multiple instructions to be executed in a cyclic manner, or maybe the instruction to be executed by using switching keyword from level by level, or maybe by using some branch conditional statements through which multiple number of jobs to be executed in an efficient way. So now the question arises, how the multiple instructions to be executed by using constraint in case of pipelining mechanisms. What are the internal behavior when that to be executed by using some constraints or conditions? When the pipeline branch instructions to be executed, in this case the pipeline branch instruction result in even worse pipeline behavior, because since the first step of the following instructions is affected by the branch target computations and must therefore be deferred. That means unfortunately subsequent phases will be taking place while the branch is being decoded and before it has been recognized as a branch. So the featured instruction may have to be discarded. For examples, suppose the branch target calculation is performed in the ALU stage of the pipelines on given figures. After that, the three instructions will have been fetched from the old string before the branch target is available. Okay, it is better to compute the branch target earlier in the pipeline if possible. Even though this will probably require dedicated hardware. If branch instructions have a fixed format, the target may be computed speculatively waves. That means during the decoding stage, thereby reducing the branch of latency in a single cycles. To note that is, in these pipelines there may be still hazards on the conditional branch during the dependency on the conditional code result of the instruction preceding the branch. Some RISC architectures define that the instruction following the branch is executed whether or not the branch is technique. That means here this type of technique to be known as delayed branch. That means here the pipelining branch behavior to be defined in these figures. Here we will take 5 instruction execution in parallel way by using certain conditions. When the job 1 that to be starting its executions by acquiring some data from the given memory locations and also register locations. After performing the resultant calculations, instantly the job 5 to be changes their constraints and acquiring the resultant outcomes of the job 1. So this types of changeable behavior to be possible in case of pipeline branch behavior in case are procedures. Okay, so this is the structure of pipeline branch behavior. By using this technique, which reduces the impact of these pipeline problems, they cannot remove the difficulties altogether, and the deeper of the pipelines, that is more pipelining stages there are, the worse of this problem that to be find out. So that for reasonably simple procedures, there are significant benefits in introducing pipelines from there to 5 stages long. But beyond this, the law of diminishing returns belongs to apply, and the added cost and complexity outweigh of the benefits. And that means here the pipelines clearly benefit from all instructions going through a similar sequence of steps, and the procedures here with very complex instructions where every instructions behave differently from the next and add to the pipelines. In 1980, the complex instruction set microprocessors of the day was not pipelined due to the limited silicon resources. So the limited design resource and the high complexity of designing a pipelines for a complex instruction set. But in general way, there are 2 types of pipeline techniques to be used in case of CISC and also RISC. But by default, as we know, the ARM processor to be normally based in RISC concept, that means reduced instruction set computer concept. So it to be follows 2 pipelining techniques for executing all of the individual instructions and multiple instruction executions. So how that will be possible? That will be possible by using 2 ways. The first one is the 3-stage pipelining and the second one is the 5-stage pipelining concept. Generally, the three-stage pipelining concept to be used when any simple instructions we have to need executing by using one clock cycles. Here, the three-stage pipelining concept to be whenever they are decoding all over the data value. Here the register bank which stores the processor state, it has two read port and one write port, which can be each to be used for accessing any registers, plus an additional read port and an additional write port that gives special access for R15s and the program counters. Here the additional write port on R15 allows it to updated as an instruction counters how many instructions we have to execute it. But in this case it will be provides two bus like your barrel shifters bus by using your B bus, and another one is the A bus. But whenever we have to execute it all over the data value by using three-stage pipelining concept that is very easy in nature. But here the three-stage pipelining concepts that cannot be executed any types of complicated applications in an efficient way. And here the memory bottleneck problems to be arises. So for avoiding all over this concept, it provides another types of pipelining, that's your 5-stage pipelining concept. Here the 5-stage pipelining to be provides 5 stages for executing any types of complexity applications in an easiest ways, and also it to be provides another facilities for converting all over the CISC data, that means complexity instructions set computer data on the format of RIC, reduced instruction computer set format, so that it uses the concept that's your 5-stage pipelining. But whenever that uses the 5-stage pipelining, here the bottleneck problem have not. But here each individual instructions to be requires more than one single clock cycles. That means here the clock cycles that may be extended as the data that to be holds. So how that to be used? That to be used by providing different types of performance increases through which the processor to be executed in an efficient way. So what are they? Increase the clock rate and also reduce the average number of clock cycles per instructions as compared to three-stage pipe. So in today's class we'll learn what is pipeline, that means how the procedure to be executed by using this concept any individual instruction and number of sequence steps for providing CPU utilization in much more ways, and also hardware utilizations in an efficient manner. And also after that we have to learn the concept or the process of the pipelining stages. That means by using which stages all over the individual instructions to be executed in an efficient ways, like your phase, records, then memory, ALU, then registers, and also again registers. Okay. After that we have to learn the concept about pipeline hazards. That means whenever multiple number of jobs that to be executed by using overlapping natures, in this case the next job to be also possible for acquiring the resultant outcomes of the first job for its manipulations. And also it to be provides another functionality if the programmer to be needed for executing next job before the completion of the first job, that to be also possible. Then after that we have to learn the pipelining branch behavior. That means by using a certain conditions how multiple number of jobs to be executed and parallel way in case of pipelining, that all things we have to learn by using the concept of pipelining behavior. For today's class that's all. If any conflict or any confusion in your mind, then you can ask me with the help of comment box. That's all.